Yes. Next sprint, I have defined you. Next, another example. Yes, another example of Fourier transform. Yes, example 2. Yes. Here, find the Fourier. Find. Yes. Find Fourier cosine transform of Fourier cosine transform. Find the Fourier find the Fourier. Here the question is just sine transformation. Sine, okay. Sine transform of the question is given as f of x is 1 by x into x square plus a square. The question is this one, okay. Or you evaluate, or yes, this question can also be written as evaluate. Yes, evaluate fs means sine of 1 by x square plus a square. Yes, okay. Now yes, we start from problem here. Okay. Now here we write down we start from the definition of the Fourier sine transform. Okay, the solution is example number 2. The solution, this is defined as, yes, we have, yes, definition of this is Fourier sine transform. Yes, we have, yes, f p f s p, yes, Fourier sine transform, or you say that Fourier of sine transform, yes, which is equal to f of s, yes, which is equal to 0 to infinity, yes, f of x, yes, function which is given here, each and everything which is given, yes, and now f of x and sine of px dx, okay. And according to here f of s sine transform of this, the function is given here is 0 to infinity 1 by, the function is x into x square plus a square sine px dx. Is clear? This is the question. Let us suppose that this is I again. Okay. Then differentiating equation, let us suppose this is 1. Yes, so differentiating, yes, differentiating 1, yes, with respect to, yes, p, yes, we have di by dp, which is equal to di by dp, which is equal to differentiating this p respect to, so we get 0 to infinity, yes, and here is again cos, differentiating this, so we get cos x means px, yes, x cos px and divided by x square plus a square dx. Yes, clear? X cancel out, so you get, here you get, this is equal to 0 to infinity cos px divided by x square plus a square dx. You get this is di by dp. Let us suppose that this equation here we suppose I is 1, so we suppose this is equation number 2. Yes, clear? Again differentiating this equation. Yes. If you again differentiating, yes, okay. Now, again differentiating, we get d2i by dp2 is equal to minus of 0 to infinity, yes, x sine px divided by a square plus, yes, x square and dx. Yes, because here you see it differentiating with respect to p. Okay. Yes. So, yes. So this is again is equal to, this equation can be written as 0 minus of 0 to infinity. Yes. Minus 0 to infinity. Okay. Minus 0 to infinity, and now here is x multiplying and dividing. If you write down this one, x here and also x here. Okay, so this term become x square sine px, and here is x a square plus x square dx. Now this can also be written as minus of 0 to infinity. This term can be written as x square plus a square and minus of a square. Okay, sine px, is divided by x into a square plus x square. If you break these terms, yes, dx are again. So you get minus of 0 to infinity x square, this one, if you take this term, this dividing this, then sine px by x, sine px by x dx, yes, minus plus, so plus a square 0 to infinity sine px by x into a square plus x square dx. And since we know the integration of this is, we know, since we know that 0 to infinity sine px by x dx is equal to pi by 2. Yes, earlier we have proved it. Okay, so this can again be written as d2i by, so d2i by dp2, dp2 can be written as, here in place of this is minus of pi by 2, and this term is again is the I as in this term. I is equal to 1 by x into x square plus a square. Here you see which is the same next term. So you can say that here plus a square I. Yes. Okay. Or this equation can be written as d2i, yes, by dp2 minus a square I is equal to minus pi by 2. If you write d as d by dp, then this equation can be written as d square minus a square, yes, I is minus pi by 2. Okay, now students, you find out the solution of this this differential equation. Okay, so you can get this solution is I is equal to complementary function is m square minus a square is equal to 0, that is plus minus a, and also integrating of this is, so you get, or you can get, yes, the particular integral from here, so you get the solution is a e to the power minus ap, yes, plus b e to the power ap. And particular integral similarly you can obtain here. Yes, this is the form of d square minus a square, that is the form of by inverse of the particular integral form. So you get plus of pi by 2a square. Yes, minus of a is here, so you get pi by 2 a square. Okay, let us, this equation is next one is 3. Yes, here you write 2, so you here write is this equation is 3 here. Okay, and again if you differentiating this di by dp, so you get a, yes, minus of a e to the power minus ap, yes, plus b e to the power ap. Yes, you get this one. Let us, this equation is 4. Okay, now from equation 2 if we substitute, yes, from equation number 1, when p is equal to 0, p is equal to 0, here if we substitute in equation number 1 p is equal to 0, then sign of 0, that is you get I is equal to 0. Okay, I is equal to 0. And now from equation again 2, yes, from 2, yes, when p is equal to 0, yes, so we have 2, which is this one equation. Yeah, this is equation. So di by dp, which is equal to, so here is from 2 di by, yes, di by dp, which is equal to, yes, di by dp is equal to 0 to infinity dx by a square plus x square. Okay, and also you know the integration of this is tan inverse of 1 by, yes, 1 by tan inverse of x by a, that is you get the integration is 1 by a, yes, tan inverse x by a. Okay students, and taking the limit 0 to infinity, yes, you get this is pi by 2, yes, so you get the value is pi by 2a. Yes, clear? This is di by dp. Okay students, now we putting p is equal to 0. Now, yes, p is equal to 0 in equation number di by dp is equal to 0. If you substitute in equation number p is equal to 0 in equation 3 and equation 4. So if 3 equation if you substitute, then a, yes, a p is 0, so a plus b is equal to, yes, a plus b is equal to, first one is if p is minus of a, yes, here is equal to minus of, because I is 0, because here I is equal to 0, so it become minus of, yes, minus pi by 2a square. Yes, clear? From equation number 3. And also from 4, if you substitute p is equal to 0, then which is equal to, here is minus a, yes, minus a 2 pi, which is given, that is minus a, yes, plus b is equal to di by dp, and di by dp is dp, which is given as 2 by, here is also, yes, okay, just a moment. If you differentiating with respect to di by dp, then a is again here. Okay, a is, okay, we have write down here minus of a of, or we say that yes, my a of minus of a here is, and also here is a. Okay, if we differentiating with respect to p, then coefficient of a is again here a minus a minus of a, this one. Okay, so here is again, here is a, and here is also a, which is equal to pi by 2a. Yes, clear? So this is again is equal to, so this can be written as minus or minus a. Let us suppose that this equation is 5, and minus a plus b is equal to pi by 2a square. Yes, clear? A is common here. Okay, now solving the equation number 5 and 6. Okay, solving 5 and 6, we get a is, yes, solving, yes, okay, solving equation, this one 4 and 5 and 6, sorry, last equation, yes, 5 and 6, yes, we get a is, yes, a is equal to minus pi by 2a square, and b is 0. Yes, so substituting here in equation of I, yes, so I is given here is I is equal to 0 to infinity, yes, sin px, yes, dx divided by x, a square plus x square, yes, and which is equal to, if we substituting a, and which is equal to minus of, here is in equation number, here you substituting, last one is in equation I. Yes, I is again here is I is equal to, yes, next one, yes, so I is, first problem is here, no, not is here, here is the base side, yes, here your I is this one, this other, so I is equal to, this is equal to, we get a, and b, a is minus of pi by 2a square e to the power minus ap, yes, plus b of, yes, and so which is equal to minus ap plus, here is this is equal to this, plus for p is equal to 0, so this is equal to, we get pi by 2, yes, a square, pi by 2a square. Yes, clear? This is equal to a, yes, now just in equation number a here, from 3, yes, you say that from equation number, okay, first, second, and now next one in this equation here is, yes, this equation, you can say from equation a, b is 0, so plus, is clear? From 3 we say, you can say from, yes, from 3. Okay, students, so pi by a square, you get this one. Okay, student, I think you have clear. Now taking the common, which is pi by 2a square, and that is 1 minus e to the power minus ap. Okay, and this is equal to I of this is, and I, which is the sine of I of this is, okay, which is the sine transform of this one. Yes, here the sine Fourier sine transform of this one, you get this one. Yes, student, I think you have cleared this question. In next video I have defined you some other questions. Okay, thank you.